Advanced Financial Modeling, Topic 10, Capital Budgeting, Learning Objective number 6. We're going to perform sensitivity analysis of an investment. So what is sensitivity analysis? Well, if you think about the models we built so far, we've assumed that all the assumptions come true, and we have one possible outcome, that NPV we calculated. Sensitivity analysis allows you to consider more than what is expected to happen, allows you to consider what could happen, and that maybe makes you make a different decision. So when we talk about sensitivity analysis, what it usually includes is the expected base case, which is what we've already done for the two projects, both the condo and the Walmart automation. But we also want to do maybe a pessimistic and optimistic scenario. So what if things don't go as expected? What is the NPV, IRR, revenue, and cash flows, and so on? And what if things go better than expected? So we're going to look at those scenarios. We'll also do a break-even analysis. On the condo, what level of appreciation do you need for the NPV to be a certain value? For Walmart example, how much of a sales lift do you need for this project to have a positive NPV? We also do data tables, and then last one we do Monte Carlo simulations, where we compute the many iterations of the NPV, IRR, and then compute maybe the mean NPV or the probability that NPV will be positive. So let's look at an example here of the Walmart automation. So on the Walmart automation, what I did here is I went ahead and calculated, or I'm sorry, I decided that I'm going to have a pessimistic base case and optimistic scenario. This is the one that we had just done in the last topic. And then I determined that and I say there's a 50% chance of that base case happening. And then I have a 25% worst case and a 25% best case. So there's a 25% chance that the pessimistic situation happens. In that case, the CapEx is not 30 million, it's 35 million. On an optimistic scenario, it's as low as 25. The scrap value could be between 0 and 1 million. The labor savings, I put between 6 million and 8.6 million, again with that base case of 7.39. The inventory savings I have here between 1 and 1.5. And that sales lift. What if there's no sales lift? Or what if there's a 9 million sales lift? So this is how I actually did this. I actually had to go to the spreadsheet. I had to manually type in for the pessimistic scenario, replace 30 with 35, 25 with 0, 739 with 6, and so on. And when I did all that, that NPV turned out to be 8.71. And then I just recorded this value here by typing in 871. Again, we're not using the IRR in this example because the sign changes more than once. And then I did the same thing. I changed all those values to these good values. And I came up with a $33 million NPV. All right, so then what do you do with this? Well, what you can do is get a risk-adjusted NPV. If I take 25% chance of getting a negative 8 million, plus a 50% chance of getting 15 million, plus a 25% chance of getting 33 million, the risk-adjusted NPV is actually $14 million. I then did some break-even analysis. If you go to your spreadsheet, and what you might do is say, well, how much sales lift do I need to make this a positive NPV project? So what you do, you just do data, goal seek, what if, goal seek. I would set NPV to 0 by changing sales lift. And when I did that, it gave me a number of break even of a negative sales lift. So it looks like I'm pretty good. I can lose sales and still have positive NPV project. When I did the labor savings, I said set NPV to 0 by changing the $7 million a year. And I needed to have a labor savings of $4.86 million per year. That's the break even. So this allows you to say, well, what are the chances I'm going to save at least $4.86 million? And CapEx, I said, well, if I set NPV to 0 by changing CapEx, I can spend up to $41 million. So these give me break-even values. And the last thing over here, what I did is I went ahead and did a data table. I looked at the labor savings and the sales lift, and I put in some reasonable values. Remember, this is my base case of 739 and 750, and that gave me a $16 million sale NPV. But if labor savings are 3 and the sales lift is 0, I lose $20 million. So this allows me to do some sensitivity analysis. Lastly, what you can do is a simulation. Now, for a simulation, what you might want to do is select, say, several key variables, say sales lift or cost or OPEX. Choose which distribution, and the ones we can use right now are normal, uniform, and triangular, because those are the ones we've been working with. And then we'd run, say, 10,000 iterations of random variables for those, and then have 10,000 possible NPVs. And then what we could do is just calculate the average NPV over all of those scenarios. You could also do the standard deviation of the NPV. You can also do confidence intervals. I'm 90% confident the NPV will be between this value and that value by taking the 5% lowest and highest. You can also even show a histogram. Here are all the possible NPVs on these 10,000 scenarios. So the assignment will include some kind of NPV assignments or NPV of a project. So that'll give you an idea of how you can augment this sensitivity analysis report with a simulation. Just a technical note here I put here. If you choose if you do a simulation and all your variables, your stochastic or probabilistic variables are symmetric, meaning if you choose normal distributions for all your variables, or if you choose a uniform distribution where the expected value and the high and low are symmetric, so maybe you expect 10 and it could be 15 or 5, that's symmetric. Or you use a triangular where it's a perfect triangle where the center of the triangle is between the base, the base angle, the base points. If you choose symmetric distributions for those variables, the mean NPV is going to be exactly equal to the base case NPV, because there's no asymmetric nature there's no asymmetric variables. So I'm just going to mention that you will get the actual base case NPV if you assume if you assume symmetry in all your variables. So in this topic, we talked about sensitivity analysis for an investment to help you make a decision.